Okay, so why don't you take a second, try and do the problem, and then when you are done, you can replay the video, or you can start the video again, and then we can go over the problem together. Alright, so let's get rid of that. Now, this is talking about percentages equaling other percentages, right? So what they're saying is you have 4% of s is equal to 3% of t, and they also let you know that s is greater than 0 and t is greater than 0. Okay, so if s is greater than 0 and t is greater than 0, then you can write out this 0.04, that's the decimal version of 4%, of s is equal to 0.03, which is the decimal version of 3%. So this is 3%, that's 4%. So that is kind of what we're saying. They're saying 4% of s, which is right there, s times 0.04, is equal to 3% of t, t times 0.03. Alright, so that's our equation. Now, if you had 0.05% of s, or 0.05 of s, is equal to 0.05 of t, the only way this could be true is if s was equal to t, right? Because that would be 0.05 of the same thing being equal to each other. If s and t were different, then this wouldn't work. Alright, so this is the case, then s and t are equal. What happens if s is 0.04 and t is 0.03 and they're equal to each other? This means that 4 1/100ths of s is equal to 3 1/100ths of t. Or in other words, less of t is needed to equal more of s. Alright, so t is actually going to be greater than s, and therefore you only need 3% of it to equal 4% of s. Alright, so because you can see that this number is smaller, 0.03 instead of 0.04, you know that this number has got to be bigger than this number in order for this equation to balance out. And that's how you know that t is greater than s. So quantity B is t, so we're looking at answer B, which is that quantity B is greater than quantity A.